Okay, so if you need some help with equilibrium shifts, stop here and take a look at this. What you can do first, if you'd like, is to go to my website and print off the worksheet. So if you look at my website, you can go to the equilibrium estimates and base section, and then if you scroll down and keep scrolling, you'll see the link to the worksheet, and then you can come back and we can go through the examples. So the first one that we're taking a look at, if you're ready to go here, is a concentration change. So if you add NaNO3 to the system, so Na positive, because it's aqueous, and NO3 ions are being added in. In this case, there's nothing that we see in terms of the species within the system, and there's nothing that's going to react to take anything out of the system. So this first reaction has no shift. There is no effect on the system. Now our next one, we're adding in NaCl aqueous. So you have Na positive, Cl negative. We're directly adding Cl into the system. If you add in, you shift away. So this would be a left shift, or shift to the left. Our next one, you're adding silver nitrate, so Ag positive and NO3 negative. This time we're directly adding in Ag positive. So if we were increasing that, again, you shift away. So we're going to shift once again to the left. Moving on to this next equilibrium system. Again, we have that aqueous system. We can write down these ions. Oops, I don't want that there. I would have sodium positive and SO4 negative, 2 negative. So we see this ion directly. We're going to be adding in, you shift away. So if it was on the product side, you shift towards the reactant side. So that's to the left. And then this last one, sodium nitrate being added in, Na positive and NO3 negative. Again, we're taking a look. We don't see sodium positive or NO3 negative in our system, and there's nothing that will form a solid to take it out of the system. So this has no shift because there is no change, adding those two ions in. Now, moving on from there, we have complex ion removal. Now, this worksheet that we're taking a look at is being nice to us because it's telling us exactly what's going to be formed or what's going to form a solid in both of these. Now, if it doesn't say, you would have to check your solubility table. If you're in Chemistry 30 in Alberta, that is on page 6 of your data booklet. So you'd be seeing what's reacting with those ions to form a solid. So in this one, it's telling you if you add in NH3, it forms a complex ion with silver, the positive ion, sorry. So what that means is it's going to leave the system as a solid. So that's leaving the system, that's going to decrease Ag positive. And if we're decreasing, you shift towards what's being decreased. So this is going to shift to the right. Same idea with this next one. If you're adding a substance, so it's not telling us what we're adding in, but it's telling us we're removing Fe3 positive. So Fe3 positive is going to decrease in concentration. So if we're decreasing, you shift back towards what's being decreased. And that's another shift. Sorry, that's another shift to the left. So just to kind of take that in, we're always trying to maintain the equilibrium system. So if you add in, you want to shift away so that we can make more reactants to balance in, or products, depending what it is. And if you take out, you want to shift back to what you're taking out so that you can replace it. Moving on. Sorry, I'm just waiting for this to catch up. Here we go. So the next one is adding in a pure solid or pure liquid. So this is essentially a little bit of a trick question, because if you're adding in a solid or a pure liquid, those have no effect on an equilibrium system, because an equilibrium system has to be all gases or all aqueous substances, or the only time a pure liquid would affect the system is if every single substance was a pure liquid. So right now, if you add in more solid, so if we add in more of the AgCl or the CaCO3, there's going to be no effect. So for both of these, no shift. And again, that's because solids and pure liquids are not part of our system. Now, the next one is your pressure change. Pressure change could also be a volume change. So when I teach this, what I tell students, what I always remember is if I increase volume, that would be the inverse of decreasing pressure. I move to the side with more moles. So I mentioned that I always write that on my paper. As long as I have that, I can figure out the rest. So for instance, the opposite would be true. If I decrease the volume, that is an inverse relationship with pressure. Pressure has to go up, and you would move to the side with more moles, less moles, sorry. So if you remember that, you're fine with these pressure changes or volume changes. The other part here that you want to remember is a pressure and a volume change only affects systems that are in a gas state. If it's not in a gas state, a pressure or volume change won't do anything. So looking at the first example, if you increase pressure, so increased pressure would be this one here, you're going to the side with less moles. So on the reactant side, you have a total of 4 moles. On the product side, you have 2. So we are going to shift to the right because we move to the side with less moles. Sorry. The opposite, decreasing pressure. Decreasing pressure is what we're seeing up here. And then you move to the side with more moles. So same idea, just taking a look. There's 2 on our product side, 3 on our reactant side. So you're going to shift to the left so that you're moving to the side with more moles. Okay, the last one you want to take a look at here is a temperature change or a temperature shift. So if you don't know if your reaction is endo or exothermic, you might have to do Hess's law short to figure that out first. Then you know what side to put your heat on. For this one, if you're increasing temperature, just like a concentration change, if you're increasing, you shift away. So we're going to shift to the left. If we were to decrease temperature, you would shift to the right to replace it. If it's endothermic, that would mean your heat is on your reactant side. So the reactants and then your system and products. So if we increase temperature on the reactant side, you're going to shift away. You're going to shift towards the product. So this is a right-hand shift. Those are our changes that we want to take a look at. I hope that you found this helpful. If you did, please subscribe. Please check out my website. It does have all the topics of Chem 30, and it also, just kind of an example here, you can start to scroll down to see what exactly you might need help with, and then there's links to the video. I hope you did find this helpful, please let me know in a comment or let me know what type of video you're looking for, and as always, thank you for watching.